Greetings. Welcome to Machine versus Mathematics channel. If not one, in many cases, if you would like to find the asymptotic value of a signal in the analysis of PID controllers, say proportional integral derivative controllers, who is going to help you out now? Yeah, there is only one theorem. There is only one theorem, that is final value theorem. Final value theorem. Now he is going to help you out. You know how? Using this I can find say C of infinity or say X of infinity without even finding inverse of the transformation. I don't require to go for inverse Z transform or say inverse Laplace transform. As we have a discrete time signal in this case, we will take inverse Z transform. That means we need not require inverse Z transform to find the value of our time domain signal at n approaching infinity. That means it is as follows. Limit n tends to infinity, say x of n. If limit n tends to infinity x of n exists, then definitely, if not definitely, let's make it like this. Limit z tends to 1 minus z power minus 1 x of z exists. Okay, let's remove also this, then here let's put again if here. If limit n tends to infinity x of n exists, and if limit z tends to 1 minus z power minus 1 x of z exists, then we could say like this. Then limit n tends to infinity x of n is equal to x of infinity is equal to, we could say, limit z tends to 1 minus z power minus 1 x of z, where x of z is unilateral z transformation of this x of n. Alright, now the fact is this. Now there are two conditions for this to happen. Okay, that means x of n must be a causal sequence, x of n equal to 0 for n less than 0, and second one is the ROC of this 1 minus g power minus 1 multiplied by this unilateral. See, x of n is in this case only right-sided sequence, not left-sided sequence, because x of n equal to 0 for n less than 0. Only in this case final value theorem can be applicable, so that I can find this x of infinity without inverse z transformation. Alright, so ROC of 1 minus z power minus 1 x of z, say poles of, let's make it even straightforward like this. That means poles of this fellow must lie inside unit circle. Alright, so poles of this 1 minus z power minus 1 x of z must lie inside unit circle. Now what if I take on the unit circle? What if I take on the unit circle? Is this case is okay? If I have poles of this on the unit circle, is this final value theorem okay? You can comment down your answer in our comment section below. Okay, so anyways, let's go to our problem now. So now, based on this above fact, now what do you do is this. So we could say like this. So C of n, small c of n, this is okay. That means now at n tends to infinity, so C of infinity is equal to, you have limit z tends to 1 minus z power minus 1. I'll take it now C of z. Okay, so so now finally what can we do? Now we can find this. So limit z tends to 1 minus z power minus 1. So what is C of z given to us? So C of z is given like this. So this is z power minus 1 multiplied by 1 minus z power minus 4 divided by 1 minus z power minus 1 whole square. Don't try to plug in this z equal to 1 in this. If you do so, you would get maybe 0 by 0 form or infinity by infinity form. So these kind of things will make your stuff undefined. So therefore, if I put, of course, if I directly put z equal to 1 here, I will get 0 by 0 form, right? So therefore, let's simplify this further if we have any other case involved in this. Limit z tends to 1. Okay, so I can, let me make it this way. 1 minus z power minus 1. This is z power minus 1. Now this fellow we can write like this. 1 minus, we can write 1 minus z power minus 2 plus multiplied by 1 plus z power minus 2 by 1 minus z power minus 1 whole square. Okay, so anyways, these two are ruled out now. Now this is what? Of course, 1 minus z power minus 4. So this fellow is nothing but multiplication of these two. Okay, so you can multiply these two, you will get 1 minus z power minus 4 here. That's fine. Now further we can do something. What is that? Further we can do something, that is this. So limit z tends to 1. I have z inverse here, I mean z power minus 1. Now like 1 minus z power minus 4 also we have 1 minus z power minus 2, because anyways I just want to cancel this out as well. So therefore I can make it like this. 1 plus z power minus 1 multiplied by 1 minus z power minus 1. So this fellow 1 minus z power minus 2 is nothing but multiplication of these two factors. Now here we have this fellow, we have 1 plus z power minus 2 all divided by 1 minus z power minus 1. So happily again these two are ruled out. Alright, so these two are ruled out. Now what are we left with? Now of course I think we have here 4, right? So in our question also we have 4. C of z equal to 4, I mean 1 by 4 times. So I'll take 4 here. 4, sorry, I forgot to take 4. So now this limit z tends to 1, z power minus 1. So 1 plus z power minus 1 multiplied by 1 plus z power minus 2 divided by 4. Okay, now if you plug in this, so on the left hand side what do you have? Left hand side you have C of infinity. Yeah, according to basic definition we have C of infinity. So therefore C of infinity is equal to, if you plug in z equal to 1, so what you get now? 1 multiplied by 2, this is again 2. If I put z equal to 1, you get 2, again here we have 4. So therefore the answer is what? 1. So C of infinity is equal to 1. See, nowhere we found inverse z transform, but still we could be able to find, we could be able to find the infinite, the final value of this C of n. Okay, and the final value of this C of n at n equal to infinity is 1. That's it. Okay, so therefore if you want you can take a snap of it followed by this, and that's all for today. Thank you. This question is asked in GATE ECE 1999 for 2 marks. Okay, thank you.